You've probably started sweating thousands of times throughout your life. When it's hot, during a workout, or simply spending time outside on a warm day. Most of us don't think much about it. We notice we're sweating, wipe it away, and keep going. It's such an ordinary part of everyday life that we rarely stop to think about it. But scientists did. They asked three simple questions. What is sweat? Where does it come from? Why do we need it? The first question scientists wanted to answer was surprisingly simple. What exactly is sweat? By collecting and analyzing sweat samples, researchers discovered that sweat is made up mostly of water. Dissolved in that water are minerals such as sodium, chloride, potassium, calcium, and magnesium, along with small amounts of naturally occurring compounds including urea, lactate, traces of ammonia, and amino acids. Scientists now knew what sweat was. Back-end index pointing right, where does it come from? Knowing what sweat was answered only part of the mystery. Scientists still needed to discover where it came from. By studying the skin, they found millions of tiny structures called eccrine sweat glands, distributed across almost the entire body. Unlike many other mammals, humans have an exceptionally large number of these glands. Researchers then uncovered something even more remarkable. Sweating doesn't begin in the skin. It begins in the brain. When the brain detects that your body temperature is rising, a region called the hypothalamus activates the sympathetic nervous system. Those nerve signals travel to the eccrine sweat glands, telling them to release sweat onto the surface of the skin. Scientists had finally discovered where sweat comes from. But another question remained. Back-end index pointing right, why put sweat on the skin? Scientists had now answered two important questions. They knew what sweat was. They knew where it came from. But one mystery still remained. Why release sweat onto the surface of the skin? To find out, researchers studied what happened as sweat evaporated. They discovered something remarkable. Sweat itself doesn't cool the body. The cooling happens when sweat evaporates. As liquid sweat changes into water vapor, it absorbs heat from the skin and carries the heat away. Scientists had finally uncovered the immediate purpose of sweating. But their discovery raised an even bigger question. Back-end index pointing right, why was removing heat so important? Scientists had discovered why sweat is released onto the skin. It helps remove heat from the body. But that immediately raised another question. Why is removing heat so important? To answer it, researchers turned their attention to what happens inside every working muscle. Every time a muscle contracts, it transforms chemical energy into movement. But movement isn't the only result. Only about 20 to 25% of that energy becomes movement. Most of the remaining energy is naturally released as heat. That means every step you take, every object you lift, every flight of stairs you climb, and every workout continuously generates heat inside your body. Scientists now understood where that heat came from. The next question was obvious. Back-end index pointing right, what happens if that heat isn't removed? Scientists wanted to know what happened when the heat produced by working muscles continued building inside the body. What they discovered surprised them. The body doesn't wait until overheating becomes dangerous before responding. Instead, the brain begins protecting the body much earlier. As core body temperature rises, the brain gradually reduces the signals it sends to working muscles. You experience that protective response as fatigue. Your body isn't simply running out of energy. In many situations, it's also slowing you down before rising temperatures become dangerous. Scientists had uncovered the body's first line of defense against overheating. But fatigue wasn't the only consequence. Back-end index pointing right, what else happens as body temperature keeps rising? Scientists soon realized that overheating wasn't affecting just one part of the body. It was triggering a chain reaction. As body temperature continued rising, the heart had to work harder to circulate blood, while more blood was redirected toward the skin to release heat. At the same time, sweating gradually removed water from the body. If that water wasn't replaced, blood volume began falling, making circulation even more demanding. Researchers also discovered that excessive heat started interfering with normal cellular activity. Enzymes became less effective, chemical reactions slowed, and thinking and coordination began to decline. The longer body temperature continued rising, the more systems struggled to function normally. Scientists had uncovered something remarkable. Overheating wasn't a single problem. It was a chain reaction spreading throughout the body. Backhand index pointing right. What happens when the body can no longer stop that chain reaction? Scientists had now uncovered the chain reaction caused by overheating. But they still needed to answer one final question. What happens if the body can no longer stop it? They discovered that every protective system has its limits. If body temperature continues rising, the brain can no longer regulate the body's temperature effectively. The heart, circulation, and other organs come under increasing stress, and cells begin to lose their ability to function normally. At this stage, overheating can progress to heat stroke, a medical emergency that can damage the brain, heart, kidneys, and other organs. Researchers had finally uncovered the real danger. Overheating wasn't simply uncomfortable. It threatened the body's ability to survive. That discovery led to the final piece of the puzzle. Why did preventing overheating become such an important survival advantage for humans? Scientists had finally reached the answer. Sweating wasn't important simply because it cooled the body. It was important because cooling protected the body's ability to keep functioning. By preventing dangerous overheating, humans could remain active instead of being forced to stop. That meant they could continue searching for food, reaching water, escaping danger, protecting their families, and completing the tasks that survival depended on. Scientists realized that by protecting body temperature, sweating also protected the body's ability to keep functioning when movement itself could determine survival. Scientists had solved the mystery. Sweating evolved because it helped protect humans from dangerous overheating when staying active could mean the difference between life and death. Today, our lives are very different. Most of us no longer depend on sweating to hunt, travel long distances, or escape predators. But the adaptation remains. Every time your body temperature begins to rise, whether you're exercising, working in the heat, or simply walking on a hot day, that same cooling system is activated to protect you from dangerous overheating. Every drop of sweat is a reminder that your body still carries one of the remarkable adaptive systems that helped our ancestors survive and continues protecting us today. Adaptation is survival.